Your future is not what you think it is. What if everything you think you know about the future is wrong? We have this tendency to see time as a straight line. It's like an arrow shot from the past, flying through this moment and landing in a single set future. We imagine our lives as a movie that's already in the can, just playing out scene by scene. But the most fundamental, most tested science in history, quantum mechanics, tells a completely different story. It suggests the future isn't one destination, but a sprawling river of possibilities. And we're just now learning how to read the currents. Now, this isn't science fiction. This is the world according to the single most successful theory we have. And it paints a picture of a universe that is stranger, more mysterious, and ultimately, way more empowering than you've been led to believe. To really get it, we have to leave the comfortable, common-sense world of classical physics behind and take a trip down the quantum rabbit hole. And what we'll find there might just change how you see reality itself. Section 1. The predictable world and the first crack in the mirror. For centuries, our universe seemed to run like a machine. This was the physics of Isaac Newton. It was all beautiful, predictable clockwork. If you know everything about a billiard ball, its position, its speed, you can predict exactly where it's going to go. This idea was scaled up to the whole cosmos. The universe was just a giant billiard table, running on fixed laws where every single effect had a clear cause. In that kind of universe, the future is just as locked in as the past. We might not be able to predict it, but only because we don't have enough data. In principle, it's already written. This view is comforting, it's intuitive. It feels like the common sense reality we live in. But around the turn of the 20th century, as scientists started poking around at the world of the very small, the world of atoms, the clockwork universe started to fall apart. They found a world that refused to play by our rules. A world of pure chance, probability, and mind-bending weirdness. The first real crack in that classical mirror came from an experiment so simple, yet so bizarre, that it still fascinates physicists today. The double-slit experiment. The setup is straightforward. You fire tiny particles like electrons at a wall with two slits in it. You'd expect to see two bands on the detector screen behind it, right? Like tiny bullets hitting a target. But that's not what happens. Instead, the electrons create an interference pattern, a series of many bands, as if each electron wasn't a particle at all, but a wave that went through both slits at the very same time and interfered with itself. But here's where it gets truly strange. If you place a detector by the slits to see which one the electron actually goes through, the pattern vanishes. The electrons suddenly start behaving like proper little particles again, creating just two bands. The very act of measuring the particle's path changes its outcome. It's as if the universe holds off on choosing a single reality until something forces its hand. This single experiment was a devastating blow to the idea of a fixed, predetermined future. It showed that on the most fundamental level, reality isn't a solid thing. It's more like a fog of possibilities, waiting for an interaction to snap one of them into focus. Section 2. The quantum rabbit hole, superposition and the branching river. This fog of possibilities has a name in quantum mechanics: superposition. It's the wild idea that before it's measured, a particle doesn't have a definite state. It exists in all its possible states at once. Think of a coin spinning in the air. While it's spinning, it's not heads and it's not tails. You could say it's in a state of being both. Superposition is the quantum version of that, but for everything about a particle: its location, its speed, its spin. It's only when we make a measurement, when we force the coin to land, that it chooses a state and becomes either heads or tails. For a long time, this was the standard explanation, known as the Copenhagen interpretation. It worked for doing the math, but it left this huge, nagging question. How does our measurement cause this collapse? What's so special about looking? Then, in the 1950s, a physicist named Hugh Everett came along with a truly bold idea. What if, he said, there is no collapse? What if it never collapses? Everett argued that the core equation of quantum mechanics, the Schrödinger equation, describes the whole universe, and that includes us. And if you follow its math all the way, it says that when a measurement happens, the universe doesn't shrink down to one outcome. Instead, it splits. The particle doesn't choose a path. It takes every single one. So when the spinning coin lands, the universe branches in two. In one branch, you see heads, and in a parallel, equally real branch, another version of you is looking at tails. This is the famous many worlds interpretation. It's one of several compelling ideas about what's really going on, and it suggests that every quantum event, every moment of chance, creates new universes. All the possible outcomes actually happen in their own separate parallel worlds. This means there isn't one future. There's a constantly branching, ever-growing tree of futures. Your life isn't a single track. It's an infinitely complex river, splitting into countless new streams at every moment, each one a real, tangible reality for a version of you. Section 3. The Revelation. Time is not what it seems. If you take many worlds seriously, it completely changes our idea of time. That straight arrow of time we all imagine is just an illusion. According to this view, time is a branching tree where every possible future is realized. But the story doesn't even stop there. Some of the latest theories push things even further, suggesting time itself might not be fundamental at all. A number of physicists now propose that time is something that emerges from a deeper quantum process: entanglement. Entanglement is that spooky action at a distance that bothered Einstein so much, where two particles become so deeply linked that their fates are intertwined, no matter how far apart they are. A theory called the Page and Wouters mechanism suggests that for an observer inside a system, time emerges because of the entanglement between them and the rest of the universe, which acts like a clock. But for some godlike observer outside the whole universe, the system would look completely static and timeless. In this view, time is really a relationship. The flow we feel is just the feeling of the universe growing more and more entangled, more complex. This doesn't just demote time from its top-tier status. It suggests that time is a personal, observer-dependent experience, woven out of the quantum fabric of reality. So what is the future? It's not a place you're speeding towards. It's a vast landscape of possibility. It's not a story already written, but a story with an infinite number of possible drafts, all coexisting in a state of potential. Whether those futures are all real, happening in parallel worlds, or just a spectrum of probabilities, every interpretation of quantum mechanics points to the same mind-blowing conclusion. The future is not fixed. This is the kind of idea that stretches the mind and makes you rethink your place in the universe. If you find this stuff as fascinating as I do, and you want to keep exploring the biggest questions out there, make sure you subscribe and hit the bell so you don't miss our next trip to the frontiers of science. Section 4. The Implications. Navigating the River of Possibilities. So what does this all mean for you, living your life in this particular branch of reality? If the future really is a branching river of possibilities, does that mean we can learn to steer? Can we choose our future? The answer is a tricky one. It's both no and a really powerful yes. No, you can't just wish for a different future and make it happen like in a movie. The laws of physics, even the weird ones, aren't that easy to break. As far as we know, there's no way to jump between these branches or go back in time to undo a mistake. The yes comes from understanding the power of our choices from a new perspective. While the connection isn't literal, you can think of your actions as a way of navigating this river. You aren't just a passenger being swept along by the current. In a metaphorical sense, you're at the rudder. This quantum view of reality, where the future is open and full of possibilities, gives us a new way to think about our own agency. This perspective can help free us from the mindset of a predetermined fate. The quantum world tells us that at every moment, countless potential futures lie ahead. And while you don't control every quantum particle, you absolutely control the big picture choices that shape your life. Choosing to learn something new, to start a new project, to have that difficult conversation, these aren't just actions. You can think of them as the moments where you guide your path forward, influencing which possibilities become more likely for you. This doesn't give you superpowers, but it gives you agency. It means the future isn't something that just happens to you. It's something you are actively helping to create, moment by moment, choice by choice. Conclusion. We started with that simple, intuitive picture of time as a straight road, but a dive into the quantum world shows us a landscape that is so much more grand and complex. We've seen that interacting with the world changes it. We've looked at the idea of superposition, where reality is a haze of potential. And we've considered the mind-bending possibility of many worlds, where every outcome splits off into its own parallel stream. We've learned that time itself might not be the bedrock of reality we always assumed, but something that grows out of quantum connections. The future isn't a single point on a map. It's a vast, branching delta of potential, a multiverse of possibilities. And this isn't just some abstract science lesson. It's a different way of looking at our own lives. It replaces the cold, clockwork universe with one that is alive, participatory, and brimming with potential. You are not a cog in some giant predetermined machine. You are a co-creator of your reality. And that leaves us with one final lingering question. If the future is a branching river of infinite possibilities, and your choices are what guide you down its currents, which future will you navigate toward?